Hey guys, okay, so week 14, week 14, cycle 2, science. We have two experiments again this week. Number 165 and number 171 in the Van Cleve's science book. I'm going to do number 171 first because I have the materials sitting here, and the first one's a whole lot easier. So, what we're going to do, I'm going to move this so you can see this bowl that I have in front of me. It's just a glass bowl. It's full of water, and then I have sprinkled pepper, just regular table pepper on top of it. So the instructions say sprinkle the pepper over the surface of the water, which I've already done that. And then you guys are going to have these little cups, and I've got dish soap that I'll bring. I tried this with a toothpick a second ago and it didn't really work. So I've cut the absorbent tip off of a cotton swab, and I'm going to use the end of that, see if that gives me a little more surface area to work with. But you're going to dip it in the soap, and then you're going to dip the wet end into the bowl with the pepper and see what happens. And that worked a whole lot better. So hopefully you could see that. After just a second of the soap being in the water, it pushed all the pepper to the outside of the bowl. So what is happening is that there's a combination of different things that's going on here. We've got the surface tension of the water that is holding the pepper up. That's why the pepper is floating on top. But then the soap actually kind of acts as a two-sided reactant. So one part of the soap molecule is bonding to the oil that you would want to use the soap for, like the food on your dirty dishes. And then the other molecule is reacting with the water so that all of the soap and the oil that you want taken away get washed away with the water. So there's a couple of different concepts that are great to talk about here. One, molecules and how molecules work, how molecules bond together. When the soap gets put in the water, in the free part, the soap is actually breaking the surface tension of the water. Well, the water molecules want to stay together, but because the soap is breaking it, they try to go away from the soap, and it is pushing the pepper away when it goes. So we can talk about surface tension, we can talk about molecule bonding, we can talk about how something breaks the surface tension of the water. And let's see, what is this saying? The opposite side of the pepper specks pulled them toward the opposite side of the bowl. So again, it's just the soap that is breaking the surface tension of the water, and the pushing the water that's drawing away from it is pulling the pepper away as well. Again, Nicole Liam on CC Connected has some really great diagrams in her write-up of this, where she talks about surface tension and the different things that float on top of water, and then what can break that surface tension. So if you've got older kiddos especially, that would be a really great thing to talk about. But even with the younger kiddos, you can introduce concepts like why we would want to break the surface tension of something like this, and what are ways in which we can be good stewards of our environment, and what are ways that we can be good stewards of just any of the things that God gives us by cleaning them up and keeping them nice. So that is experiment number 171. Experiment number 165 is on page 92, I think. And it is called cold foot. And so the concept of this experiment, what you're going to have is you're going to have some aluminum foil. And I've got a couple of just cheap little bathroom mats or rugs or whatever. And I'll bring them. And heads up, moms and tutors, any moms who want to participate, if you don't want your toes to show or whatever, put on Band-Aids or get a pedicure or whatever, but you'll be taking your socks and shoes off for this one. So you might want to let your moms know too, in case they want to give their kids a bath the night before. Anyway, what you're going to do is you're going to take some aluminum foil and you're going to put it on the tile floor, and then you're going to take this little bath mat or rug and put it on the floor, and you're going to take off your socks and shoes, and you're going to have one foot standing on the rug and one foot on the aluminum foil. And obviously your foot is going to feel colder on the aluminum foil than it does on the carpet or the rug, even though it is the same room temperature. So the room doesn't change temperature because there's foil or because there's carpet. But the concept is conduction, so how heat gets transferred through solids. You can talk about conductors that help transfer energy. You can talk about insulators that don't transfer energy as well. So when your foot is on the aluminum foil, aluminum is a better conductor than carpet or fabric, and so that your foot will feel colder on the aluminum foil because there's more heat transfer. We can also talk about heat transfer through air, which is called radiation. We could talk about heat transfer through water, which is called convection. Any of those concepts, again, the older your kiddos are, the more of those you would be able to introduce. But you can also just keep it really, really simple by helping your kids begin to think about the things that feel colder to the touch than something that might feel warmer to the touch. Also, you can ask them to think about how long would they have to stand there on that piece of aluminum foil for the piece of aluminum foil to get warmer, and how long would it take for them to warm up that rug. So it's vice versa. Yes, my heat transfers out more easily on the aluminum foil, but that also gives me a better opportunity to warm it up more quickly. So all of those are things that you could make as talking points of the cold foot experiment. That's number 165, and that is cycle 2, week 14 science.